looking into what's excitation-contraction coupling. Basically, excitation-contraction coupling is going when you have the muscle going from the electrical stimulation to the physical movement of that muscle. Now, I've been working on that, but we've got kind of an essential link here that we have to go through. So we've already gone through the neuromuscular junction, where that initial excitation of the muscle membrane starts. We've discussed action potential propagation or action potential conduction, how it moves along the sarcolemma. We now need to figure out how it goes deep into the muscle cell itself to reach those contractile elements that will be the end of the excitation-contraction coupling. So we'll start off with, remember, the action potential travel along the sarcolemma. We already have it in the muscle, it's moving along. We need to get it down deep into the muscle itself. To do that, we need to have the depolarization or the action potential travel down the T-tubules or the transverse tubules. Once that occurs, that will trigger the voltage-regulated calcium channels, which are found along the T-tubule, to be excited or depolarized. That means those channels, those voltage-regulated calcium channels, are going to open up, and the calcium is going to go down its diffusion gradient. So high-low concentration. This is going to pour out of the terminal cisternae, the sarcoplasmic reticulum. It's going to pour out into the muscle cell itself. So this is kind of the very last stage just before we start the actual contractile phases. So let's take a look at this. And this one I'm going to blow up full screen, make it a little easier to see. We're going to start with a little quick review and go into the new step. We're starting with a review of the starting part up here. That is going to be the neuromuscular junction. So remember, initially, the action potential is going to travel down. That means it's going to come down and excite the voltage-regulated calcium channels here. Remember, we have these voltage-regulated calcium channels. That means the calcium is going to flood into the cell. As that calcium floods into the cell, that's going to cause these synaptic vesicles to fuse with the actual end or that muscle membrane there. Sorry, with the neuron membrane there. Once they fuse, via exocytosis, they'll release the acetylcholine. That's his little blue dots. They'll go across to the synaptic cleft to the motor end plate. Now, the motor end plate, again, remember, was that part on the muscle? That is going to have these ligand or chemically gated channels. Acetylcholine binds, the channels open up. Sodium and potassium are both going to flow through in opposite directions. This flow is going to allow for the creation of graded potentials. So think small local depolarizations. What happens then is, if they can all add together to reach threshold, so negative 55 millivolts, they can trigger an action potential of starts. Once you hit threshold, an action potential starts, then it's going to travel down the sarcolemma, down the muscle membrane. Remember that to do this, though, this is action potential conduction or action potential propagation. Those sodium ions, they're flooding the cell through the voltage-regulated sodium channels. Remember what they're doing here is sodium is going to be flooding in the cell. All these positive ions are moving down an electrochemical gradient. They're moving from the area of a high concentration of sodium to low concentration and a positive environment to a negative environment. So they're going down the electrochemical gradients. That's where we finally end up with this new spot now. We have the T-tubules. Those sodium ions, that depolarization, that action potential, is going to travel down the T-tubule. As it travels down the T-tubule, there are going to be these channels along the T-tubule. The channels are going to allow the calcium to leave. And as that calcium is leaving, so these are all calcium, 2+. As that calcium's leaving, it's going to flood through the entire muscle cell. As it floods out into the entire muscle cell, it's going to try and increase the binding rates on troponin. This little yellow spot there is troponin. Now, that troponin is going to go through a shape change or a conformational change. We'll need to pick that up in the next video because that's a whole different process now. But this is by the end of the excitation-contraction coupling. Because at this point now, once that troponin starts to move, we're going to start to create an actual physical movement in the muscle. So now we're not just exciting the muscle, we're actually creating the movement. That's the coupling aspect. The fibers come together, all those different thick and thin filaments start to move, the muscle is contracting. So we've gone from the neuromuscular junction, down the sarcolemma, which is the action potential conduction, down the T-tubule, finishing off this excitation-contraction coupling. Just about there, just about ready to have a muscle move. So the next step to pick up, which will be the cross-bridge cycling, will be finally the physical movement of the muscle.